This should be day one of solving exponential equations. There's going to be a handout that goes with this, 5.4, solving exponentials. And in addition to that handout, there's going to be this, I call this just a degree chart. It has different numbers raised to different powers, and I'll show you how to use this as I go through. So let's start here. Just by inspection, just by looking, I have 2 to the x equals 2 to the 4th. What does x equal? Hopefully you see that x has to equal 4. For 2 to the x to be equal to 2 to the 4, then x has to be 4. Then you would have 2 to the 4th on the left and 2 to the 4th on the right side of this equal sign. And we use this principle when we have two exponentials and they have the same base. We can cancel out the bases, set the exponents equal to each other, and solve. I'll show you what I mean down here in this next one. I have 6 to the negative 3x minus 2 equals to 6 to the negative x. So they both have the same base of 6. I can cross out the 6's and set negative 3x minus 2 equal to negative x. And then use the steps of algebra to solve. Let's see, so I would add 3x to both sides of the equation here. Negative 2 equals 2x. Divide by 2 on both sides of the equation, and I get x equals negative 1. And you can take that negative 1 and plug it back into the original exponential equation in place of the x and check to see that, yes, they are still equal to each other. So this becomes negative 3 times negative 1, which is 3 minus 2 is 1. And when I put negative 1 in here, I get negative 1, which is 1. So I do have 6 to the first equals 6 to the first. So that does check. But what happens more often is we're given exponential equations where we don't have the same base. And that's where this other handout comes in. This is my degree chart. And what it has, along the left-hand side, it has the numbers 2 through 10. And across the top, what these are actually the exponents. This is like to the first power, to the second power, to the third, fourth, fifth, sixth. Those are the exponents. So what I mean is like 4 to the third power is 64. On the other side, these are negative exponents. Negative 1, negative 2, negative 3, and all the way down. And these use the same base. Like, say I have 7, let's do this. 7 squared is 49. But if I keep going, 7 to the negative 2 is 1 over 49. It uses that negative exponent rule. You flip it and change the sign. 9 squared is 81. 9 to the negative 2 is 1 over 81. And it could work also if you use fractions as the base. So like 1/9 to the negative 2 would be 81. 1/9 to the 2 would be 1 over 81. But usually we just kind of ignore the fractions. And when we come to them, we convert them to whole numbers. So I'll show you what I mean on this next page. So I'm given this equation, 2 raised to the x plus 2 power equals 32. Now, if I can write these with the same base, I can cancel out the base and solve the exponent. So I'm going to go back, and I'm going to look in this whole sheet. And I'm going to look for where 2 and 32 show up in the same row. So right here I have 2 to the first power, and 2 to the fifth power will give me 32. So I can rewrite this as 2 to the x plus 2 equals 2 to the 5th. 2 to the 5th is 32. I'm just rewriting it in equal but different forms. So now I have two exponents with the same base. Cancel out the base, set the powers equal to each other, and solve. And you can also substitute back into the original equation and make sure that it's still equal. So here I have 2 to the 3 plus 2 is 5, so 2 to the 5th equals 2 to the 5th, so this does check out. One last example, and this one has a fraction, but I'm still going to do it the same way. I'm going to look for 16 and 1/4 in a way that I can write them with the same base. I'll look at this degree chart. 16 I can write as 4 squared, and 4 to the -1 would give me 1/4. So I can write both of these numbers as with a base of 4. So 4 squared is 16. I'm going to bring down the original exponent, and I'm going to end up distributing that 2 here. And that equals 4 to the -1. So now I have two exponents with the same base. Cross out the base, set the powers equal to each other. 2 times 3r minus 2 equals -1. Distribute. 6r minus 4 equals -1. Add 4 to solve, and then divide by 6. And it looks like r is going to be 1/2. And you can substitute back in here and see if you get the same answer. Last thing I want to show you, it's not actually a problem, it's just an observation. And whenever you run into something like this where you have a 1, just remember that any base can turn into a 1 by raising it to the 0 power. So what I mean, for this example, if I have 6 to the 2x and I want to write 1 as a power of 6, I can use a 0 exponent because anything to the 0 power equals 1, and that will work for any number. So now I could solve the same way. Divide by 2 and I get x equals 0.